We'll start. I'm going to share the screen. Okay, so we're continuing with presentation of grid software solutions. I'll just take a quick recall to what we did in last few days, last week. So basically, we started with ID Builder and SEL Matrix. With the ID Builder, we did explain how to create virtual IDs with real logical nodes and logical devices, data objects, data attributes. We learn about services, importance of services, what they are representing, what capabilities ID can do based on services. And then we did create one virtual IED, and we exported into ICD file. So after that, we talked about SEL matrix system specification. We told the system specification is process in which usually utilities can specify their system requirements by drawing the single line diagram of their substation and by assigning logical node and logical devices across single line diagram objects. And we showed how we can use embedded logical node designer to allocate logical nodes within single line diagram. And we also showed how we use virtual or real devices to allocate or replace the virtual ones. And then we went through the process of the end goal of system specification with the SSD file. And the SSD file was the file that contained substation section of the SEL language. Then we moved on to the system configuration process. The system configuration process is the process in which we perform horizontal and vertical communication settings, namely goose and sample value, publisher-subscriber relationship, and also vertical client-server MMS between clients, gateways, HMIs, and server IDs, usually represented by relays. We went through the tab configuration. We went from tab by tab, talked about how we do communication part, how we create subnetworks, how we assign IP addresses, how we draw COM block diagram that represents communication interconnection between IEDs. Then we started with data flow engineering, and data flow engineering was done by first creating or adjusting data sets and content of data sets, whether we use existing data sets or whether we create new data sets. Then we talked about control blocks, and we went into the process of configuration of report control blocks, goose control blocks, and sample value control blocks. And then once we created control blocks, we did Then we did association of Goose publisher subscribers, sample value publisher subscribers, and clients and servers. The end result was fully configured system that showed all IDs and their input points or inputs represented by external references. And then we showed how visually you can represent the system using visual diagrammer. And we also told that you can perform the entire configuration process using the same visual diagrammer. At the end, we talked about wizard, documentation wizard, and option to quickly generate some points, or generate some documents that could represent your points list, your single line diagram, your allocated node, your data sets, association with data sets and control blocks, and so on. When we finished SEL matrix, we did next day we did discovery and SimLab. We said for the SimLab is basically always works with this server engine, and the server engine is the main core simulation program that can at this point accept 62050 protocol, but in the future is going to accept DMP and IEC suite of protocols. And we said when you go into the simulation, it's a quite easy process, but you need to start by starting the server engine. And we said that server engine could be running on your local machine, but could also be running on the remote machine. After you start server engine, you open SimLab and you import SEL file. You got 3 steps to do. You place IDs in simulation, you configure them, and you activate them. All other IP allocation will be automatically done by SimLab, and at that point, your SEL file, however is configured, will be fully simulated by the SimLab. We didn't go into the details of all options of SimLab in Discovery. It is quite hard to run a live session and show all the features. So today I'm going to just go through the presentation of SimLab and Discovery to kind of give you an idea of what capabilities you will find, but I will not run live sessions as that slows me down. And when I finish that, I will tackle a grid runner as a complex development environment that you can use to create your own programs. The grid runner by itself is a 5 days course, and there is quite a lot to learn. So luckily we do have a very, very good presentation that takes you step by step in configuring three programs of different complexity, of simple complexity, medium complexity, and high complexity. And by completing these 3 programs on your own pace, you will have better understanding of the capabilities of Grid Runner. So for today, I'm going to cover Discovery SimLab features that we didn't cover, and I'm going to go to the presentation of Grid Runner so that you have full understanding of at least level of applications. Sample value analyzer is something that I might be able to No, I won't be able to run because I don't have process bus with me. But it's a very simple application that all it requires it at the beginning. You select whether you want to connect to a live stream or you want to open recorded session. And if I find some of these, I will actually use it to yeah, I have some to show you the features of sample value analyzer, so we can do that too. All right, so I'm gonna go back to training part, and you do have these exercises, both for discovery and for SimLab. So we did configuration of SimLab server, we did time sync, we did MMF buffer report controls, data logging and setting groups, rarely any IED support. So I will skip to that, but something that is excuse me, something that is you might find interesting are service tracking, state sequencer, and simulating ComTrade files. So that's what I'm gonna run to these presentations. Service tracking are not supported by many IEDs. There are some IEDs that support that, but if you find these IEDs, it's extremely useful to actually utilize functionality of service tracking. So we'll briefly explain what service tracking properties are. We'll show how to configure for objects for reporting. We'll also show how you can monitor using report monitor and using track view. Okay. So here it's asking me to connect to IED and go through that. But what is important to know is that service tracking property provides means for logging or reporting commands issued by any client over control blocks on controllable object, and also server responses to these requests. Okay, so remember we talked about controls. We had operated controls, select before operate with enhanced security, direct operate, and so on. We also did configuration of control blocks. We enable, disable goose messages while being online. Well, all that, if IED supports service tracking, all these activities on control blocks, on any control that IED has, will be logged internally by a relay. So relay will say, okay, I have 2 clients, and this client initiates select before operate, and I have logged that event on that time. And also I'm logging the respond of myself, of relay, whether this command was executed correctly or not. Then you can also see the logs of buffer and unbuffer reports for data change, for quality change, when they happen, when the events happen, when fault happen. These will be initiated by control blocks, and service tracking will log that. Service tracking will also log every goose message that is being issued by the relay. So having that, all that information is quite useful to have to get basic confirmation that an IED is responding to controls being issued, and also can alarm if some of the controls fail to execute, whether this is for control operate or whether this is for MMS reporting or goose messaging. Service tracking is realized using logical node LTRK. And it has data objects and data attributes that represent attributes and service parameters of the control object and control blocks. So basically, if an IED supports tracking services, you will find logical nodes LTRK, and within these logical nodes, you will find data objects and data attributes that represent service parameters and service tracking attributes, each representing attributes of report control. So this can be, you can find this under the, if you look at the logical node LTRK and you just double click on any of these data objects and you will see them listed. This is for buffer report control block, unbuffer report control block, goose control block, log control block, setting group, log control block, and so on. So you double click on object of your interest and you will see the parameters, services and parameters. And you will find the information about, in this case, what caused this buffer report control block to operate, when, by whom, what information was sent, and so on. The attributes representing service parameters are at the top in this red square, and they are first object reference. This is object reference of the buffer report control block to which this tracking services applies to. Service type, what kind of service was issued by a client. If there was error during that execution, what kind of error code that is well described in the 6150 standard, and originator IP address. And this IP address is done in hex numbers, so you can see, and obviously the time when that happened. Here on this particular presentation, attributes are still with no values inside is in after startup state. So when you have no values, that is when your IED reboots for the first time. And in this presentation, we're running to request for buffer report control block and see the changes. Okay, so in this particular case, we went to buffer report control block of this test IED, and we issued enable action. So we enabled control block that was initiated IED to start sending buffer reports at least on integrity period interval. And then based on that action, you can go back to logical node LTRK1 to object buffer report control block tracking. And by reading values, you will see that The values are populated of the parameters. Object reference is now reference of that buffer report control block. Service type, this enable action was nothing else but client initiating function set buffer report control block values. The action was correct, so there was no error, and originator IP address was this hex format, COA8, so that's 192.168.9.64, whatever. Let's see. E4. 228, yeah. And the timestamp when that happened. Okay, again. Issuing enabled. This is what we are getting. Also, all data attributes representing buffer report control block attributes, which are in the bottom part, in the blue rectangle, have been now updated to correspond to buffer report control block attributes. And you can see the report enable is true, data set, name of the data sets, configuration revision, optional fields being sent, buffer time, sequence number, what triggers, integrity period. So if you are, so this would be in your relay, if relay supports logical node service tracking. So if logical node supports service tracking, basically you can read by MMS this logical node and have complete understanding of what's going on of this potential connection with this client with address 224. Okay, that is the value. By reading all logical nodes LTRK values, you can know whether there is any faults going on execution of 61850 commons in your relay. If there is any error, you would be basically provided with information. Now, in this next sample, another report control block, BRCBE, was again enabled, and by reading the logical node tracking services for that particular buffer report control block, new values have been updated. So this presentation takes you in getting these for simulation. You would not need to worry because SimLab by default supports service tracking and can simulate an IED that potentially has service tracking functionality. This is now trying to show an error code in this step, and what happened is user is entering a value in one of the report control block attributes, and it's trying to set integrity period while buffer report control block is state enabled. Now, when the buffer report control block is enabled, no parameters can be changed. That's the rule. So when the control block is enabled, it means it's communicating with a client. And while it's communicating, none of the properties can be changed except general interrogation. That's the command that is issued by the client itself. So in this exercise, while enable, user is trying to change integrity period. And it's typing a value of 10,000 and followed by the write command. And the service tracking is getting error code, instance locked by other client, meaning while this change of value cannot be performed because this control block is owned by the client that enabled it. And no other clients can perform any changes to that control block apart of the client that performed the enable action. That client is only allowed to perform writing of general interrogation command, and that general interrogation will make relay send all data, the reference data set by exception. So now there is a consolidated view of data set containing service tracking objects. And this exercise is showing an example of using FCD, functional constrained data service tracking data set. So what the user of this program did, he brought all these service tracking blocks, data objects, and he placed it in a data set that he configured. That way, any change in any of the tracking objects would initiate this data set to be sent to the client. That's how would you normally make best use of your service tracking objects, by putting them into a data set and by putting them into MMS buffer report to a client that wants to know about these changes. So here it says, we're going to use service tracking objects by means of logging or reporting. To do so, first we need a data set containing service tracking data objects, and to reference this very data set to a report control block or log control block. So basically, once you create data set, you will need to find a unused report control block and make reference with this report control block. You can alternatively, if log control blocks are supported, you can tie it to log control block too. So in this presentation, it says that this data set was already configured. It's called functional constrained FCD service tracking data set. And you can see that beside buffer report control block tracking data object, many other tracking objects are also included. For Goose, double position controllable object, single position controllable object, and so on. You take an unused report control block and you tie this data set with this control block and you make it a buffer report. You use trigger data update, click OK, enable, and as a result, you would receive reports with the tracking. So here is another exercise that deals with changing the state of Goose control block, whether it's enable or disable. In this instruction, we're going to disable goose control block. Before that, we go into the tracking view, and we open both report monitoring and report tracking view. So in a report monitor, now we're going to use service upon goose control block triggering an event. It goes to goose control block and enables control block. As soon as enable, it disables it again. So enable, disable. As a result, the previously, obviously, this goose control block is part of this data set here. This goose control block, third from bottom. So by doing enable, disable, this data object will log these events. And these events happen by performing IXC action, enable goose control block and disable goose control block. Because that particular data set is part of this report control block, we're going to see it as a buffer report. And for that reason, we're asked here to start report monitor to see that buffer report control block, and tracking view to see the values. After we start these, we go into the goose control block and we perform enable, disable. And this is what report monitor shows. Data update report was captured, and we have values associated with this report. So we have set goose control block value set to false. That's the part when it was disabled. For enable, this set goose control block value will be true. And he says, observe that the set goose CB values, so set goose control block value service request has been issued, and that the current value of goose enable attribute as value of false. Moreover, IP address of client issuing request as well as the time step are also delivered. So the client that did make that disable enable was again this client 228. There was no error, everything went correctly, and this is the timestamp of that action. Now, it is important to notice that any client which has enable reports would be informed about activity toward goose control blocks regardless of which part has issued a service request. So that is the very good functionality because most of your, especially controls, will be performed by the logic of your programs, will be performed by goose coming from other relay, and so on. And as an independent client, you want to be able to get all that information and not just changes that you as your client is doing. So you have visibility of everything. This is now a view of the tracking data in the tracking services view tab. And obviously you can see that the values have been updated. Service type, error code, issuing IP address, time, value, and because this data object is part of a data set and control block, name of reference, data set, and control block. This is an example in which client discovery is issuing control, something that I did last Friday. direct with normal security control is being operated. And in the background, a relay that support service tracking, and SimLab is the one, will actually log all the information. So this is what was happening. The presentation takes you to controllable object position. It's asking you to perform direct operate with normal security. When once you operate control, you will see in tracking view that values have been updated, and this is for the double point control tracking object. There is also single point control, direct operate, select before operate are they belong to class double point control. So double point control recognize that object that was on which was performed this action was this QA1C switch position. The service type that was issued was operate. There was no error during that, so successful operation performed by this 192.168.9.228 client on this date, and control value became true, and some other control number time, whether it's test and whether any check was performed, interlocking sync or test by mode. So this is service tracking, and it's not really hard to do it. You just need to create an STL file, and I believe in your folder you have the file that is actually designed to perform this exercise. Okay, so that was service tracking. Do you have any question about service tracking? It's very, very useful. Unfortunately, not all relays support it. Actually, there are just few of them that support. And if you find that functionality, it's extremely easy for the integrity of your system. You can have a consolidated view of every single remote action being performed on any object, controllable object in your substation. That means any controllable object, any control block for goose, for sample values, for client server, for logs. All that is being monitored. The next presentation is about ability to simulate. I remember in one of the exercises we had to change the value of data in SimLab, and we had to do it by going through the IED model and searching for that particular data object, and by putting value for data attribute and manually writing the value to see new value being updated, and then consequently the new goose message or MMS report. Now, there is a facility in SimLab that allows you to perform simulation of group points at the same time, and to make sequences of these data writes. So this presentation about using state sequencer will show what are the functionalities of the state sequencer, how to configure it when you are performing simulation of SimLab, and we'll monitor these simulated values with Discovery. So basically, when you are in this is your SimLab. Remember, when we open SimLab, we are asked to import SCL file. When we import the SCL file, we said we have 3 clicks. We place the ID in simulation, we click on configure, and we click on activate. When that happens, the ID is activated, it's being simulated with its IP address, with all control blocks, goose control, report control blocks, all the capabilities based on services listed in the ID services section. Now, this is an image in which ID is already placed in simulation mode, so it's activated. And there is a tab called Simulate. When you click on that tab, Simulate, you will get content of the tab with all these icons. We use some of these icons to filter data sets, switch gear, logical node with the starting letter X, measurement. That's how we found measurement group. But there is also very first option is sequencer. So when you click on sequencer, you will get this pop-up window that will ask you to either create a new sequence program or to open existing one. This is like a management place. If you previously created sequences, they would be listed here. So this page is really performing management of existing and new sequence program. Because there is none in this dialog, we are instructed to click new button to configure a new sequencer program. Okay, so when that happens, you are giving this dialog box. So this is your sequence program, and these are some general information that you want to set up. The first one would be name of your simulation program. This is called simulation of start and operate signals. And but automatically, at this point, you won't be able to change, but sequencer is looking for IEC 61850 points. At some point, when we support multiple protocols, we will be able to add different protocols. So you'll be able to simulate points in this program from other protocols. But at the moment, it's from 61850. The top part will stay here. I will explain later, but basically these buttons will be used to start, pause, stop, or continuously run this sequence program that we are about to configure. So this is kind of global page of your simulation program. And as you can see in the middle part is empty. This is where we're gonna add individual steps for this program. To add step, there is a option add sequence. And when we click on that, basically you are getting an interface that allows you to map individual points from your IDs. Now, if you are simulating multiple IDs, then you can add points from any ID that is being simulated. In this case, we are simulating only one, so for that reason, there is only one ID. So basically, you are searching into the list of points that you want to add in this first sequence, and you are literally drag, drop with the drag drop action, you move this data object start into the sequence, into the first step. So these are the instructions. Go and find start of the protection GSPTRC, and either double click or drag and drop technique place data attribute into the sequence. And as you can see now, in your first sequence, you have 1 point brought into this sequence. And now user is selecting value to be used when the program starts running. And the program will start running with those start-stop commands. You can add some delay to that by using this delay timer. And you can also change the duration. So you can say, let me just see if more points have been added to this. Yes. So I'm just going to run faster. Okay. So basically, the idea here is that you add not one, but perhaps 100 or even thousands of points. I know it is quite tedious work to add 1,000 points, but remember, you can save it and reuse it at any point of time. So in this first sequence, I can add hundreds, again, or thousands of points, give them initial value, and give here duration of this sequence. So when the program starts, I might say, I want this sequence to execute for 2,000 milliseconds, for 2 seconds. So I want these hundreds or thousands of points, or in this case, this point, to stay with this value general for this duration, 2 seconds. I can also find a different trigger and brought a trigger point that can complete life of this sequence, either with a goose message or a state value of another point. Basically, I'm saying this point start will stay general with value general for either duration of this time, or if any of the points listed here change the value that I want. Okay, so this is giving 5,000 milliseconds. Basically, this start general will stay for 5 seconds. So this is basically your program starts. This point goes to this value for the duration of 5 milliseconds. Now I'm changing the program by adding a new trip object of the same logical node, protection related protection trip command. So I'm adding another point with these two signals, and I'm going to provide value for the trip as well. Now, you can keep continuing and adding more points that you want to force in this sequence, in this step. There are options to delete or multiply or copy and duplicate points that you have. Normal manipulation with these variables are all available here. You can all set to 0. You can select multiple and set one value for multiple, and so on. So now when I run this program, okay, I have multiple options here. The first option is run the program. If I run the program, there is only one step in this sequence program, and that's basically put this point into this value for the duration of 5,000 milliseconds. That's what this program is going to do. Now here, it's indicated after this sequence is done, do you want me to return variable to initial state? So if initial state was is not general, it was none. So if you click on this checkbox, the program would run 5,000 millisecond STR general, and when that is completed, it will be resetted to initial value. So that is sometimes useful if you want to toggle the point on, off, on, off. You can replace the entire sequence with with this checkbox. Now, again, these top commands start, pause. So, for example, I start, and then after a second, I click on pause. This timer here will count the time, so it will stay 4 more seconds once I click on continue. This is useful if you are running some test in which you control your environment. This here is a stop, basically stops the program. And this one is saying skip the sequence. Now, in this program, user didn't create another sequence. So imagine that this sequence one, it's just one of sequences that you can configure. You can group points by data types and create one sequence for analog values, then create another sequence for digital values, one sequence for trip signals, and so on. You can add, I believe, up to 64 sequences, each filled with hundreds and again thousands of points. And when you have that, this program becomes quite powerful. Now, this button here is continuous, which means let the program go and run sequence by sequence based on this delay and based on duration and triggers defined here. Let this value be forced, and then let sequence 2 starts. And when the last sequence is completed, I want this program to run again. It's a basically loop, endless loop that will put your program into continuous change of these sequences one after another. And it's a great thing to use for simulating some large amount abnormal or even avalanche conditions. When you're running this program, there is a status here that tells you in which step is program currently, whether it's in step 1, 2, 3, and so on. Okay. So I'm not sure if I can just quickly run SimLab just to show you the interface. I'm not gonna simulate anything. Okay, so simulate sequencer. Here. So new program, new sequence. So this is test sequence program. And right now I have nothing, but I'm adding first sequence, add sequence. We call it sequence N1, duration 2000 milliseconds. I could also do this process trigger and go into a value, but I'm not going to do that. Now I need a value. So to add points here, I'm using tag browser. And I want to do this. Let's take this position. Drag drop. Control model. Timeout. Operate. And so on. Okay. And then once I create first, so some of these are not controllable. So I shouldn't be actually adding these. The red one means these are not settable. So nonetheless, my point was here that once I create the first sequence and create all these points, I can add another one. As you can see here. So this will run first for 2 seconds. And then I will have this for 1 second. And I'm going to run these points. Let's do protection related. Start. Here you have filters to filter how to get into the point of your interest. Quite nice feature here. I want to do general. And now when I want to reset these points to different, I can use not add sequence and map again, but I can say duplicate sequence. And when I say that, then I have duplicated previous sequence, so that's sequence 3, and then I just change that to some other value. Okay. So this would be my program. I can save this program. And if I was in live session, I would be able to run the program. And the program start. This sequence here would execute. These values will be updated. After 2 seconds, sequence 2 will force these protection trip operate and start to general values. That will last for 1 second. And then these values will be changed to new values. And the program would be completed if I run just one run. If I click on continuous, then this program would loop. Basically, after this sequence 3 is completed, because I have this checkbox, all these values from all sequences will be reset to their initial values. So that will be, in essence, 4th sequence just hidden here, performed by this option. Now, when I want to watch these values, I use these 2 tabs. These are the initial values. And here events will be mapped. And I think that's captured in this presentation. Yeah. So to watch the result of your sequencer, you click on the global watch, and global watch will have 2 tabs, table view and event list view. Table view is a list of all points that are part of your sequence program and their values. initial values. When the program completes, you will receive event. In the event monitor, all these events, newly forced points, will be captured, and you will see when they happen. And obviously here, 48, 49, 1 second between them, then 5 seconds. Then this was all done within the same sequence. And then 5 seconds later, this was reset to these values. Okay. And then you can, using discovery here now, once these points are forced, you can go in discovery and see these updated points either through Goose messages or through MMS reports. So basically, user is starting the communication with this IED, and it's clicking on new data set. It's creating a new data set. It maps these trip and start objects into a data set. The idea is to create data set, to create either Goose or MMS reports, and to see how these reports are being influenced by the sequencer. So the data set is called start and trip. These two, trip and start, are placed into the data set. Data set is associated with this control block, BRCBE. And then control block is configured for integrity period and triggers, and it is enabled. Okay, and once the sequences start, you can see multiple MMS reports caused as data change, where data change was initiated by state sequencer program. And you can see the points. If you are running multiple steps in the sequencer program, then you will be getting multiple MMS reports. And again, one of the use cases with sequencer is to create avalanche conditions for your IED to see whether your either client can deal with so many reports being issued, or whether server can actually create these reports. And with our simulation tools, with SimLab, several instances of SimLab and Discovery, we were able to create avalanche of a couple million MMS reports. So very, very powerful and useful program, part of the SimLab. So here, do you have any question? If you don't have any question, I will stop here and I will take 15 minutes break. And when we come back, we'll complete a few more Goose Comtrade and maybe see some interesting discovery features, and then we'll jump into Grid Runner. Okay, so I'll see you in 10:23. Thank you. Okay, so we're going to continue with the ComTrade filed exercise. Again, all these presentations are available in the package that was sent to you. All the files associated with this are also available. So ComTrade file, how can we simulate ComTrade file? So in this activity, we're going to import ComTrade file. We're going to show how to import ComTrade file. We're going to map ComTrade file variables into the sequencer program. And we'll create sequencer according to the digital and analog channels recorded in the ComTrade file. And we'll see how to view and monitor test results. So again, it is assumed that you have your SimLab device activated with SCL file loaded, so IED is running live. And you go again to Simulate tab. And next to the sequencer icon, there is an icon Import ComTrade file. So when you click, you'll be asked to select your ComTrade file. So remember, ComTrade file comes with a pair of two files, data and configuration. So we're going to grab data file and click open. When you do that, this file will automatically be placed into the SimLab ComTrade signal mapping table. As you can see on the left side, there are the list of analog channels, current voltages, and other recorded values found in the recording file. Now, next to it is a server variable. Basically, you are asked to associate your analog and digital channels with the points from your ID model. And if you look closely to these points, you will see that you will be able to find corresponding points of the ID that you are simulating. So you have to go and map each point for each digital channel that you are recreating, or sorry, analog and digital channel that you are recreating. So it might take you a few minutes to map these files, but again, everything can be saved for future use. So for the first variable, L1 phase, you click on please select variable, and you find in your ID model corresponding measurement logical node MMXU1 A dot phase A. Now, if you are looking for current and voltages, they're going to be usually located in MMXU or M related logical nodes, or T if you are dealing with digital CTs and VTs from merging unit. So you can type logical node and filter out your tree to get faster to the point of your interest. So here we are mapping GSMMXU 1A phase A point. For example, for the relay pickup, the corresponding value would be from your protection logical node trip condition start. And again, you would go one by one, and you would fill these server variables, map them with channel names. When you finish, you will click on confirm. Now, this example is just showing selected number of points. And you will see that sequences will be automatically created based on the previous action. And in this example, 17 sequences along altogether simulating pickup signal, trip signal, and measured value of phase A current. So when you scroll down, there will be 17 of these, each representing one of the values from the recorded file. Now, to monitor these values, again, you would go to Global Watch, you would click on Global Watch, and you would see a list of points that you're gonna be monitoring, and eventually events once the sequencer program is executed. Again, to execute program, click on Start, and that Start will run you through all the changes that are written in the Comtrade file, and you would see something like that. So again, here in this example, just 3 values have been selected to be executed with the Comtrade file. And here are the values of that fault. You can see one by one points have been changed. There are times, and these times correspond with the times found in timestamps of the Comtrade file. So everything is here based on the information found in the Comtrade file, and therefore you would get accurate replica of the analog values and digital channels and all these changes that happen when the Comtrade file was recorded. So again, that was Comtrade file. Simulate goose messages, I think we did that, but nonetheless, because it's something that you'll be doing so many times, maybe it's worth going through the presentation. So its objective is to simulate goose messages and to manage goose control block and to force goose events. So you would import SCL file and you would configure server with those 3 clicks, simulate, configure, and activate. When that is activated, you can go into the configuration tab, and then you can select goose control block overview. And this is the overview of all goose messages being simulated ID by ID. On the right side, you have a publish button. When you click on that button, goose is enabled. To stop simulating, you would basically click again and disable goose message. This goose control block window presents all key parameters of goose messages, and that includes data set, destination MAC address, state number, and so on. Not all of these information related to goose are presented in your table, but there is an option, column chooser, that you can use to select all information that you want to see in this window. And vice versa, you can remove fields that you don't like to watch. So to change goose data set value and basically to trigger goose event, you can look at the data set referenced in goose definition. So you would always find the data set, and you can find data set by using filter data set. We're looking for functional constraint data goose data set. And this filter will filter out everything, leaving just a goose data set. When we click on our data set, you would see those values. You can basically come here and start changing the values. Okay. As soon as you change the value, the last state number will increase, and new goose message will be published. Okay, so that's simulation of goose messages. And there are more other functionalities. Some of them are very advanced. And that includes server, which is now not connected. But if I let me see if I can quickly start the server, just to show you some very, very advanced features. And these are strictly used for troubleshooting and making some very specific changes. This is basically going into this server engine. Here you would see all the MMS variables. So if you do understand very well MMS, you'll be able to go and make changes on either models. You can even change the model itself, or you can change some internal parameters that are not necessarily available through your 61850 interface. And again, this requires really in-depth understanding of the MMS protocol. But basically, all of these points can be also changed. Everything related to 61850 could be changed in this server configurator. So we normally don't teach our clients to use this because it can actually change the model and create some significant changes that are not really visible from this view. So okay, but that's just to know that if you are very advanced with 61850, you can go into the server and time sync we did the other day. So you're just putting IP address of your time server, and here you can see the values of round trip and jitter, along with the status of your SNTP protocol. Okay, on Discovery Lab, some tips and tricks here, maybe worth explaining. Let me see if there is anything else that might be of your interest. Dynamic data sets, goose monitoring, lab, control operations, service tracking, setting groups. Maybe setting groups. If you do have relays that support setting groups, you can use even Discovery to perform changes on setting groups. So In this objective, open and view setting groups control block, edit setting group control block attributes, and edit setting group values. So we are here asked to open a connection with an ID that support setting groups, and you can use filter setting groups to find available setting groups control block. This is the ref 615 with setting group control block SGCV. When you double click on it, you will see first some properties. It's a number of setting groups, a number of active setting groups, configuration and time associated. So if you want to configure these values, you click on configure, and you are first prompted to select group that you wanna select. You click on edit. We're editing right now group 0. So when you open group 0, as soon as you open that control block, it will get status reserved, which means that no other clients can make changes. Reserve timer parameter is now 60 seconds, indicating status of the setting group control block. This value 60 indicates that user has 60 seconds to perform changes before reservation status expire. Not too many really support that. It's an optional parameter of setting group. You click on edit setting group values, and this will expose all attributes which belong to a setting group to make changes of these values. So then you start making changes, and when you finish, you write to new value. When you finish, you click on confirm and close, and then you move on to next group. Last activation timeout keeps updating every time you perform some edit action. You can now see the new values of your settings. If you want to see new settings on your protection elements, click on protection icon. This will isolate protection logical nodes. And for example, for this time over current, new values are being confirmed. Okay, so that was setting groups. That's also available in both Discovery, and if you are simulating, it's available in SimLab. And don't get surprised if you don't see too many relays supporting this setting group. Okay, file transfer. Yeah, file transfer is maybe something that we wanna describe. So if you want to perform MMS stripe, if you want to pick up ComTrade files or any recordings in your system, you can use Discovery or any other client, MMS client, to perform that. This is now explanation how to do file transfer with Discovery. So obviously you can download file from connected ID. You can reverse, you can upload file to connected ID, and you can select and delete files in an ID. So again, it asks you to configure SimLab and to start Discovery and connect to an ID. If you have a relay, even better. If you don't, you can use SimLab to simulate that. So if your ID that Discovery is connected to support file transfer services, then for this particular ID, Discovery will tell you whether that ID supports file transfer. How basically Discovery reads the services section and looks for file transfer parameters, and based on these results, this icon will be enabled for those IDs that support file transfer, or disabled if IDs do not support. So you click on that file transfer, and you are connected to IED's file location. That file location is described by the description MMS, semicolon, // and then IP address of that IED, followed by the MMS TCP port 102. And then there will be file location with folders and file names. So first few files are ComTrade recordings. And in this case, user discovery is selecting this data ComTrade file and is also providing location where the file will be saved and performs action save. If you want to upload file from Discovery's location or the computer that runs Discovery to an IED, you will use Set File option. When you click on Set File option, your file chooser will show up, and you will select file that you want to upload. So select the file and click Open. And again, reverse to download file, use option, get file, select location. There's also option to delete file. And once you upload and download, you can now start browsing the location either on your computer or on a remote IED, and you can see that file has been updated to the remote IED. So it's fairly simple exercise, very intuitive, easy to access, and if you see file transfer icon, you know that IED supports file transfer. Once you click on it, you will see if these are available, that's again supported by an IED. If some of these actions, for example, delete file, many don't support for security reasons, obviously, then this will be disabled. So whatever it's enabled, it's available. Okay, so that was file transfer. And I'm going to run these tips and tricks in regards to some layouts, rearranging layouts. So sometimes you will be switching from tab to tab, and Discovery offers you the ability to rearrange this layout. So to perform this exercise, we're asked to navigate to Solution Explorer and open report control block and the data set that belongs to report control block. So when you double click on data set, it will open data set. Now, another option is to rearrange the layout. You can grab any of the windows that you see here and you can bring to the middle. When you bring to the middle, this light indication will ask you where do you want to move that screen, to the left, to the right, to the top, or to the bottom. And here the user is grabbing this tab, this dataset tab, and it's putting it on the right, to the right. And the end result is Now you have a report control block, you have data set side by side. And you can keep quick watch list. Okay, sometimes you want to watch several points of your interest, how the value change. Here is an example. You're connecting to an IED and you go to view option. In the view option, there is this icon quick watch. So when you click on this quick watch, this window here on the right would show up, and you can go and select any point that you want to monitor, and you want to push, drag and drop from left to right. And you add all points of your interest to that side, and you can start polling with some time interval, and all these points will be regularly updated as they change. Now again, here this quick watch is being pushed to the right side so that you have an ID3 view. You can see the value of this data object block open, but you also see the points from your quick watch list. Again, once you bring all the points, put a polling interval and click on start. Okay, monitor report without use of report monitor. So you can monitor data coming to the reports without even using the report monitor that is reported in, that is found in the report control block. The reason for that is because Discovery will update all values received from the report immediately as they happen. So instead of going into opening report by report and reading the values, user can open data object and data attributes that are mapped in the report and put it either in the quick watch list or just by looking into the data set values. How to save network traffic. So Discovery also offers users to save network traffic during session with other IDs. And this network traffic includes all communication protocols covered by 61850 standard, which is MMS, goose, and sample value. So basically, to record the traffic, you open the traffic tab, and there is on the right side option to select your network card. So basically, it would be in Discovery. Here. Here, now my wireless adapter on this computer does show up. So you click on start, and when you're finished, you click on stop, and this will capture the pickup recording that is now saved on my computer. Okay, if I probably go to downloads, I'll just see where I save it. Open. So here I grabbed the one with no traffic. So basically, automatically opens the file. It allows you to save file with the recording. So that is that option to save network traffic. You start, you stop. There is also in the setting file, there is duration of the monitoring. If you don't click on stop, it will at some point automatically stop. View status values on logical node level. So when you're browsing IDs, you don't have to dig and double click to get to data object. You can basically select the logical node and right click on it. And there is an option, view data objects of that logical node. When you click that, all data objects of that logical node will be presented with their values. There will also be timestamp associated, quality, and belonging class, common data class. How to save online configuration of a connected IED. This is very useful if you go to a substation and you connect to an IED, you can save that IED, and later you can put it in the simulation in your lab by using SimLab. So before that, you need to connect and save online configuration of that connected IED. Step one would be Discovery is able to save configuration of connected IED and export definition using file extensions supported by SimLab, SCL Matrix, and other Engineering Studio tools. So not only for simulation, you can also place it in your configuration tool. SimLab, for example, may import this definition and use it to simulate IED in the same manner as it would be done with the SCL file extension. Now, you have to keep in mind that what IED has in his memory is not really 100% representation of the SCL file of that IED. And because of that, to make files usable for simulation and configuration, Discovery uses templates to replace segments of an IED configuration file which are not visible online. Now, here's how you save. Once you connect to IED, you mark IED that you want to save, and you click on Save. Very simple. So basically, it would be, if I go to 228, you go to option, let's see where the save is. Here. Sorry, this is SimLab. Here. So this is my test IED. I can create save. And this is the extension that is internal to Engineering Studio. And again, it cannot be saved as ICD, CRD, or IID. Why? Because the online IED does not have the entire ID model loaded. And no other tools can actually create that. There are some other tools I saw that they can create, but basically they don't state that they are replacing missing information with what they believe is correct. And certainly this is not 100%, might not be 100% correctly done, or it's not done in line to what SCL file of that IED says. So for that reason, we are saving it as our extension and indicating that this file was created by Discovery, not by, if this is ref 615, it's not ABB file. Okay. I think that would be all for Discovery and SimLab and SCL Matrix and IED Builder. Obviously, again, we are running something that would be 10, 15 days training, because each of these, SCL Matrix alone is 5 days, SimLab and Discovery are 5 days training, and Grid Runner is 5 to 7 days training. So we are running these presentations fairly quickly, but the main purpose of this is to introduce you with capabilities of some IEDs or some of our software. And for that reason, I'm skipping many of these labs that we would normally do during the testing. But I think you have a fairly good indication of what you might find in SCL Matrix, IED Builder, SimLab, and Discovery. And these are one of the core of the products that we offer. Let me just deactivate this. And when I finish that, I'll explain quickly the sample value analyzer. And we don't really have any presentation on sample value analyzer because it is just a reader of sample value streams. And unfortunately, I don't have sample value stream, but I do have some previously recorded files, and they will load all the views that you can see. So there is nothing to configure in some sample value analyzer. You either click new by stream. If there is a sample value stream, it would show up in this list. Obviously, I don't have in the background anything. You can create from pickup file, and that's what I'm going to do here. I do have previously saved projects that are still on my, so I do have a saved stream before. So I'm just going to show the views that you will get. Obviously, when you are in live session, this would be updated constantly. And you can see your oscillography view in your vector view. There are zoom options. There are values as you move, you will see that every sample is actually presented with the values here. Anywhere you click, you will get new values updated with a timestamp. You can see the harmonics as they happen throughout this recording. This one didn't actually have any. You can see symmetrical components. And again, every sample is here. And you can also see the values in the form of equivalent scheme. You can see the impedance, your MV, MVARs, and so on, voltages, and so on. Let me just see if I have some fault recordings. here. Yeah, I don't have too many of these, but basically everything is self-explanatory information that you are reading. There is an option that you can actually make recordings, act as some sort of DFR. You have either your trigger, either your voltage or current, and you put lower and upper limit. And when these limits happen, the file will be automatically recorded. So you can change adapter that is connecting your process bus network. And as well here, you can perform simulation in form of pickup file. Some options here to provide different colors. This is more software components used, and there is each of our software tools will have in the view help button that will open up the manual associated with it. Okay, you can do searches here and find point of your interest. But basically, sample value analyzer reads your samples in sample value streams. You can connect to multiple streams and watch your streams. The only recording option again is to use this limited recording capability that is based on triggers, lower or upper limits, basically your hysteresis of your current or voltages. That's what this application does. SCL comparison tool, it's also so simple that there is no need for any presentation. Basically, you grab two files on the left and on the right, and you perform comparison. I'm going to try to find something that is similar. Let's say we go back to training. I want you to find these files. So for example, well, let's compare NARI with Schneider. So you place two files. You will normally perform comparison of the same files. When I say same files, something that perhaps was online, recorded with either by using Discovery or by taking CID file and original SED file, and you compare whether there was any difference. Here, obviously, there will be a lot of differences because we are talking about different files, but you will be able to quickly locate what the differences are. If you either, these are the list of differences, and you can either double click on them to get to the point where the difference is, or you can navigate through files themselves to see the difference. Now, obviously, the better view would be if I compare two files of the same type. And obviously here there is no differences. But if I go and make a copy of this file, let's just make a copy of this NARI file here. And I can open in the notepad and I can make some changes. So I'll make this 44 in the copy version, and I'll make some of the values from 3 to 5,000. And I'm going to save it, and I'm going to run in the comparison. And here I have a list of differences that are listed. Obviously, the first difference is in metadata. Metadata means something that is not related to ID model at all. It's usually name of the file or some private signatures. Obviously, the name is different. This is copy ICD, and this is the original name. Time when they were created. Obviously, this was created in 2018. This was created today. Last time written here and here. So for that reason, you can really catch any changes done on online devices. If you complete your testing, good idea is to load these online files and save them, and then you have snapshot of something that you did commission. And then later when you come in, if there is any problem, the first thing that you can actually check whether there was any changes done in any of the settings of the file. And this orange color represents the changes. The first one was in the connected AP modifier, 33 and 44. So if I double click on it, it'll actually highlight where the difference is, 33 versus 44. Or if I double click on this val, is 3,000 or 30,000 here and 50,000 here. And you can get the report of any comparison differences in this embedded documentation wizard. Okay, nothing really else. Here you can change the color of difference in metadata, what was added, what was removed, different colors, modified within the child, selected, and so on. You can choose color of your choice. No other, and there is a manual associated with that, so you can help yourself. Okay, very, very simple, but very, very actually powerful. Here you can focus on certain things. You want to see whether there was any changes in a goose message. And obviously none. Or in the ID itself, that will be related to this. Select before operate timeout. Communication section will reveal another one, and that's where the AP qualifier is. So that's how you can focus on certain areas of your interest. All right, so that was Discovery SimLab Server Engine, SCL Matrix ID Builder, Sample Value Analyzer, SCL Compare, and then this is story for itself. Grid Runner is something that is very, very powerful because it combines the entire Microsoft workflow engine with Engineering Studio. And if you do have a license, you'll be able to run it. If you can run it, that means that you will be able to run programs created by SEL Matrix. If you don't have SEL Matrix license, then even programs that are written with this, and they are in form of files with this GWFP, workflow process, Great Software Workflow Plus. So if I open this program written by Grid Runner, I will be able to get it. So on this first introduction of Grid Runner, I want you to differentiate two things. First thing is programs created by Grid Runner. They are coming in this form of so-called self-executable programs with extension GWFP. These programs are ready to use, and they usually, based on how you design them, they usually have interface of information that user needs to provide. And when you deal with 61850, the first thing that you would like to ask user to provide is a SEL file, whether this is an SCD file or a CID file that represent an ID, or let's say your relay. So if you want to create a program that connects to a relay and do certain things with the relay, you need to ask, okay, give me the SCD or ICD file or CID file of that relay. Why? So that my program knows what is the IP address, what is the ID model, how many logical devices, logical nodes there are there, what services or capabilities this IED is offering. And then based on that, I'm going to do some action. So behind this program, there is quite a logic. Actually, not this one. This one is fairly simple. This is one of those 3 programs with very low complexity. This program is saying, I'm going to do automatically, I'm going to connect to an ID. I'm going to issue a service discovery. Discovery is basically a service that is known in 61850 as a service that gives the ID model. And I'm going to abruptly terminate the connection that I establish. And as I'm doing that, I will provide test results in a form of this console, in a form of a file that will be logged. Then when I close the connection with ID, I'm going to open again and do the same thing again. I'm going to open connection, stop connection, start connection, stop, and I'm going to do that 250 times. Now, when I, as a user, I'm trying to execute this program can work with any ID, but I need a representation of an ID in form of SEL file. So when I get that SEL file, I put here in this interface path to that file, so that my program knows all the connectivity parameters. Remember, there are those connected AP parameters with a bunch of these basically all these parameters. That's all available in the file. So my program here is saying, just give me the SCL file and I'll take care of the rest. Tell me if this is an SCD file. There might be hundreds of IEDs there. Which of IEDs do you want me to connect to? And here user selects how to do it with test IED. Okay, what is the access point of that test IED? You write here. Okay, where do you want me to put the output of my program? And I say, how about you log everything in this folder on my computer? Here, what do you want to name me? What should be my name of this program? This program is named this name and short description, associate and client release, TPAA association. How many reconnections should I do? 250. Basically, all I'm doing here as a user, I'm loading the SCD file, I'm telling what the IED should be, how many times I want to repeat this, and I'm clicking on execute. Obviously, right now I'm not executed, so I'm going to get the appropriate message. But if I was, my program would execute. Now, this is the program that is written by Grid Runner Workflow Designer. Okay, this environment here allows me to create program that at the end looks like this file. When that file is open, looks like that. To run this program, to execute this, whatever the logic behind is, I must have Grid Runner license. When I have that Grid Runner license, I can actually create the logic. Now, because I do have license for both, I can actually click on Designer and I can go and see how this program is actually designed. And this here is the same as here. I can close this just with my program loaded. So it's the same environment, just with my program loaded. And my program is this. Now it does look strange, but it is actually organized based on the workflow rules of Microsoft Workflow Engine. So Microsoft Workflow Engine, if you look at the .NET, you will find what sequence is. You will find what output is. You will find what delay is. You will find what do-while loop does. You will find what if statement does and how it's constructed. And actually, all these .NET Microsoft Workflow Engine logic part is available here. So basically, we inherited this from Microsoft.NET. It's not something that we wrote the code for. We just integrated these design and workflow environment. And what we added, well, we added 61850 part. Because if you look at this program, it does have something that belongs to .NET, which is sequence. But it does have something that does not belong to 61850. And this is associate. Associate is a well-defined 61850 service. Identify is a very well-defined IEC 61850 service. release connection is very well defined 61850. So we broke basically discovery. Okay. We broke into individual IEC 61850 functions and made these functions available as a block logic component so that you can create Microsoft workflow program with 61850 object components. And what are these object components? Well, I'll talk about ID scope, but associate is making associations. So when the connection is about to be established, the first thing is client sends association request with the server, with the relay. And this association here is something that could be positive or negative. If it's positive, then there is a connection between client and relay. This release is if client wants to release connection, doesn't want to talk anymore. And release has a rules, what information are being exchanged. Abort is aborting the communication, connection session. Identify is a request in which client is asking ID to tell its name. Get definition is IEC service that is asking ID to give ID to present ID model. Get server directory is asking ID to provide the entire server with logical devices, logical nodes. Get logical node directory is a service that asks relay to provide all data objects within one logical node. Get logical device directory is providing all logical nodes within, and so on. So all these, if you are into 61850 bit deeper, you will find them in the 61850 standard. Goose publisher, create variable, change variable, update. Ethernet interface, which Ethernet interface I want to use with my program. Start, stop, Goose subscriber. Dealing with data sets, create data sets, delete data sets, get SSH directory, file transfer. Then some combine logic with IEC 61850 function. For example, loop that says for each logical device, and then do something, read every logical node. Then there is a loop for each logical node, read every data object in a logical node. For each data object, read data attribute. For each data attribute, read the values. For each data set, give me the members, give me the values of the members. So all these 61850 services are made available as a component. You can basically drag and drop, control, operate control, select. You can basically drag and drop into your program. And when you start these programs, they are well-defined rules how you do it and how you drag and drop things. But basically, I'm going to read this. I'm going to read this program now to you. So Microsoft Workflow Engine requires that every program be placed in something that is called sequence. That's the rule of the environment. So as a result, I actually have to have this sequence. And that sequence is actually holding every single part of this program. So you can move through the sequence by going at the top, or you can get into some of these and see what's inside. But I'm going to go at the top. So my main sequence is there. I have to place it. That's the rule of the workflow. And then I'm adding something that is unique, that is made by Grid Software. It's called ID Model Scope. This here. I drag and drop. Okay. Now this ID scope is basically the core of some of the logic of this program. It's saying, well, all I need from you is give me the SCL file. Give me the SCL file, and I will know everything about that ID based on the all intelligence that I have in all these software tools, from Discovery, from SCL Matrix, SimLab, everything is embedded here. Once you have ID model scope inside the sequence, then this program is 61850 knowledgeable. It knows everything that you would normally ask program to do. All it takes is SCL file, and because SCL file could be ICD file, and when it's ICD file, then ID name is only one. But SCL file could be SCD file. An SCD file could have multiple IDs. So to deal with one ID, I need to ask for SCL file, for ID name, and access point. Because ID could have multiple access points, could have multiple network interfaces, and could be connected to multiple networks. So I'm focusing on one access point connection to one network and all the model definitions that belong to that access point in that server. I can make this because I want this program to be unique, so you can deal with any SCL file. I might want to place that as an argument. Argument means that program when I run my program, that will be available for user to enter information. And indeed, if the program has to be unique for any SCL file, then you need to ask user. When user runs the program, user has to select the SCD file, the ID, and the access point. And by making these three variables arguments, I'm actually passing into my program later, when my program is built, these three will be visible with all other arguments listed here. And if you look at this list, that list is equal to this list. Basically, when I run the program, suddenly my program has these arguments. Why? Because in my program, actually, that's how I declared. And it has some default values. I'm going to go back to the program because I promised I was going to explain what it does. So this is just the original view. You got main sequence, you got ID model scope, that scope that is very smart. Inside that ID model scope, I'm asking user, passing these as arguments, asking user to drop file name, ID name, and access point. And then there is something that I configured as called ID sequence. Well, in this set of sequences, I'm doing some action. Get workspace is something that is Microsoft related. It basically creates a memory for this program. Nothing to know about it, but it's mandatory. Now, a delay is a good way of giving your program time so that this memory allocation can be done successfully. Then I'm dropping first of my 61850 services, and that's associate. Associate is basically asking for connection. Okay, it's a built-in. As you can see, I don't need anything, any parameters. Why? Well, because remember, in my model scope, I said that user must provide SCL file ID and an access point name. That's where the IP address and all these connectivity parameters are located, so I don't have to worry. Also, that ID model scope knows about the ID model, so I can issue command identify. Identify is a well-defined 61850 service. The response of identify is the name of an ID. Again, I issue associate, give me the name of your program, and I want to close the connection. I want to release the connection. As soon as I release connection, I want to place some output information, and that output information is here. I can format the text that I want to have, and I want to get some information. What ID is this first time that I'm making release or second time, and so on. These two outputs are just some textual outputs that will end up in an output file or into a console. Now, program is completed. I have connected. I ask for the name. I close connection, and I send some output to file and to console. But then I'm not terminating program, because termination has specific command. I'm actually putting a do while loop. That I'm borrowing from Microsoft. Do while sequence, and inside that do while sequence, I have the loop. And in that loop, I am adding an increment, a counter. I have a counter to count how many times I'm doing that. And what I'm doing again associate, and I'm going to ask for the result of associate. So associate, I give a little bit of delay time for relay to respond. When the relay respond, I question, okay, what happened with the associate respond? And I'm going to have positive and negative. If it's positive, then I'm going to put an output, increment the counter, say, okay, this is the first time that he responded with the connection. I'm going to put that in the file, record that in the file, and I'm going to release the connection. When I do release is again request from relay to release connection. It could be positive and negative. For positive, I will place the text that it was successful, and for the negative, if the negative is, then my program is, relay is no longer responding to anything. So I'm just going to record that relay failed to respond, and I'm going to terminate the program. This is the end of my program if that happens. And now I'm going back into the do while loop, and I'm doing that, whatever the increment counter is, and that increment counter I can put as an argument to my program. So basically that's what program does. It keeps looping, asking for connection. When it gets connection, it asks for the name. When the name is given, it checks whether it issues the release. And if you look into the UCA test scenarios, basically, that is your very first UCA test case. These are test procedures. And our programs, written programs, are called after these procedures. I'm looking at SASS1. Here. There you go. This is the first conformance block, basic exchange. These are mandatory. These are conditional. And there are descriptions of what this is. Let me just find if I have that. SASS1. Here, this is the test. Okay, basically, this is what we need to do, and this is what results are expected. So basically, test case says, configure the client and device under the test with the correct association and authentication parameters. Client request associate, client request release. Repeat these two steps 250 times. What are the expected results? Well, we expect device under test to send associate respond positive and release respond positive. So when the relay vendors go for the certification, this is one of the first tests. Relays have to connect and reconnect 250 times without making any negative associate or release response. And that's what our program does, actually, perform this. And it creates output file. Remember, I was telling that I have a bunch of output information. Well, it records all these 250 sessions so that the result is recorded. It also records something that test was completed and shows when the test was completed, what was the device under the test, in this case, SimLab, test scenario, and here I was just running 15 times successful, whether test failed or passed. And this is the structure of the ID. That is all done by this small program. This program here. Okay. If I expand all, I get to my original view. So this is the program. This is the most simple program that you have. And we have over almost hundreds of these programs. Some of them are fairly complex. And I think in these exercises, we run this file here would have quite complexity. Oh no, that's Goose. That shouldn't be that complex. Create and delete persistent data set. This one is complex. Now, for end user, look at how simple this program is. You don't even have to know really 6950 in details. This is what the program is asking you to provide. STL file, ID name, access point. Where do you want to drop file and nothing else? This is just the name of your program that you can rename, test description, and so on. But in the background, it's actually quite complexity. This program has a lot of logic inside. Now, my point at the beginning was, I want you, and I was carried and I went to explain certain things. But the main thing is to understand two things. Grid Runner, if you can start this, that means that you have a license for Grid Runner client or the workflow designer. With that license, you can run and edit these programs. If you don't have Grid Runner license, basically you won't be able even to open this program. Now, I'll take a break here and I'll go to explain in the presentation main parts of the designer and how the program is executed. How you write program, how you execute it. What is your end result of using Grid Runner? Okay, so let's make 15 minutes break and we'll come back in 15 minutes. Okay, thank you. Okay, we continue. So in your training folder, you'll find this grid runner training along with 3 exercises. These exercises have detailed instruction how to create program, 3 different programs of
Excuse
smaller.
me,
Yes.
you forget to share your screen.
Oh, I'm sorry. Okay, I'm gonna again show that in your training folder, there is a main presentation along with 3 exercises, 3 programs of low, medium, and high complexity, along with SEL files that you need for these 3 exercises. You have fully completed programs, and you have detailed instruction how to create these programs step by step. Okay, so they are quite long presentations, some even close to 100 of the slides. So it does take quite a time to go through this. Again, normally we do it 5 to 7 days training, and you'll have to do it on your own. This is the program when completed, and this is the image of the program, and there is a program itself completed. So 3 exercises, 3 different UCA test scenarios. First one is associate and client release. Second one is create and delete persistent data set. And when you open it, there will be instruction of the UCA test lab with its number. And again, there will be detailed instruction of how to do it step by step. I'm going to run this procedure, presentation, how to use test procedures. And I also said I would explain you how what are the main components of the grid runner. So I'm going to open the grid runner client. And I'm just going to show what are major components. So this is the workflow designer, place where you create your programs. On the left side, at the top of the menu, there is designer tab. There is option to create new program. There are different type of programs that you can create. One default is a brand new program from scratch. You can develop anything. If you want to speed up some of the programs that deal with SEL files, live connections, or Goose, you have these programs that will already have some parts that are necessary embedded. So for example, when you create on Goose Publisher, you will have a sequence with publish Goose flowchart that will greatly help you in creating your Goose-based program. Option open will open existing Goose program so that you can see how the program is composed. Then here you have option to save program or run program. I'm just going to open some of these so that you can see options. So run will run your program while you are designing it. As you run the program, you'll be able to use some of these options related to debugging. Once you go into the debug state, you will be able to go step by step and see how each part of your program is performing. While you are going step by step debugging, you can pause, you can insert breakdown points, you can insert disable, and so on, and you can again continue with your execution. This is very good for troubleshooting because at the bottom here, you will see another component called activity trace. And activity trace will tell you what's going on with each individual block here and what the result of the block is. When you have an error in your program, you will be able to quickly find what's making problem to your program. Abort will abort your debugging state. These options here are several options that you can show. Properties are the properties of each of the component. This is property window is on your right side. You have toolbox that is on your left side. Toolbox is composed of individual IEC 61850 functions that are broken down into by services, models, controls, Goose, data set, file transfer, and so on. Below them are workflow utilities that are basically part of .NET framework or workflow engine framework. So these utilities control flowcharts, state machines, runtime, collection, and error handling allows you to manipulate with your program. And as you start using them, you will see what they are responsible for. Okay. You can go to Microsoft website and you can see instructions, detailed instructions of each of these components. Okay. The output box is basically a command or console that will also give you a response to your program. But in order to see messages written in the console in the output, you need to use output blocks, and you need to design your message based on, again, the rules of this environment. So if you are good with scripting programming, that it should go fairly easy with few instructions. They are quite easy to understand format of these output messages. So that's the output window. The trace window is, again, I explained that trace window will show the execution of individual components and will show you what the state is, what the variables are being used, and the arguments, what are their values, and how they are tied with activities. Communication tab will provide you with 61850 communication responses for your associate, release, abort, sending 61850 services, and you'll see the response from your device under the test. And validations is overall output that describes the overall environment messages. They are quite useful when it comes to troubleshooting. You can see where the program stopped, what was the reason for that, and so on. The outline will take your program and will show it in this form where activity is listed one after another, so you can easily move through your program. If this is easier for you than by scrolling these sequence blocks. So two ways of navigating, either through these sequences or through the outline program. Quit will quit your program, and in the view section you can just rearrange these windows. So in order to get really good at the designer, workflow designer, you need to really get a very good understanding of the .NET framework, especially this workflow engine. So that's the Microsoft part. And if you are familiar with 61850, then all these blocks will be easy to understand. Okay, in the workflow window, which is your central window, you have sub-tabs, and these tabs show what variables program uses and what arguments program uses. Variables are internal parts of the program, variables that are used in your program, and their lifetime, again, depends on the position within the sequences. That's something that you will learn by learning the workflow engine. Arguments are type of variables that you are making available to your end program. So when this program is completed, it will be composed of the start button that will execute this program from the beginning to the end. But before this is executed, you would provide to user this interface, a table in which you would ask user to populate some of the information that are required by the program. That's the interaction between your program and user. And imports here it's not configurable. It just shows what sections of the 6150 model are being utilized and what parts of the .NET framework are being utilized. If you want to go into deeper debugging, you can be browsing through these models. But again, most likely you'll never use them. They're just information what parts are being utilized. When this program is completed, when you save this program, when saved, and I'm going to go and make some changes here so that I can save it. For example, here, start Goose Publisher part. So when I save it, I'm going to call it exercise. I'm going to drop into that training folder. When this program is saved, they all look the same. When this program is saved, it comes in this format, and all programs will come in the same format. On the left side, you will have arguments or interface with the user, something that user will have to provide input in your program. You always put default values. So this is to publish Goose messages. And the program is asking how many variables, how many data attributes you want to put in your Goose message. And default value is 1, 10, I can make 100. What's the application ID? Default is 1, I can make it 10. What is the MAC address that you want to use as a Goose publishing message? What's the maximum time to live or heartbeat, minimum time? What's the Ethernet interface? And that Ethernet interface corresponds with your network cards. Okay, so there is internally, every network card is numbered, so from 1 to whatever number of network cards you have. Do you want to use VLANs? Do you want to use simulation bit? That's addition 2. And what's the delay in milliseconds between published Goose messages? So that's input for the user. And basically, if you are changing these numbers, arguments, they will be entered into your program. When you run program, you click on run button and your program runs. Obviously, I'm not in the running mode here, so nothing will run. Now watch, if I want to go back to default values, I can use compile, which will bring me default values, and this will all change to default values. You will have communication log, you will have event log and console. These are the output formats where your program will actually execute. So that's how your program looks, regardless of what the complexity is. What changes is just these arguments, number of arguments that you are providing. You're always getting communication log, event log, and console. And you can also create in your program output files. So, for example, go to dataset definition, go to this. This is the program. I think this program is explained in your presentation. It has its variables. And in the program, you can also instruct program to record the entire MMS session of this program. As you can see, that was done. There is even timestamp associated with this, so I can check. But anyways, here where the program so you have different options to follow. But here is the MMS stream with TCP. Basically, that's where the sync messages, they follow the association request. And here are the initiate request, initiate respond, some contain TCP message, confirm request, confirm response, and so on. So you can follow this stream to basically validate, to have proof of your test. And that is saved in pickup format. That program actually provides instruction for this file to be created. In addition to raw recording as a proof of the successful execution of this program, program also creates two text files. One shows compiled raw data and presented in form of 61850 functions, where you can see associate, identify, get server directory, and so on. Request and response from request from the program and respond from the device under test. And you can also see the format of the output that deals with your specific program requirements. This SDS 8 UCTS scenario requires you to create and delete persistent data sets several times. And as the program issues create data sets, and when the data set is successfully created, program logs that information. Then it goes with delete and repeats the session these 100 and so many times, 250 times. If everything is completed correctly, then program says, okay, everything is correct, test passed. If we get abrupt interruption of the program, then test result would indicate fail. And this is the test program, and this is how it looks in the designer. So again, I can use outline. Sequence is a mandatory part of .flow.net. ID model scope gives you all the intelligence of the 6150 model embedded in our software. And then you have a body of your program. This mandatory get workspace for a delay. Then program says associate with the device under test, perform identify, give me the name, and provide output. And in that output, you basically are stating that you are starting with the program with device under test with this name. If I look into the output of this program, which is written here, that's this part. Okay. This was device under the test, version and revision. In the program, that looks format of this message, string format, first, second, and third variable. And this is first, second, and third variable, followed by this string that correlates with this and that. The top part here correlates with this part here. Then program says, okay, we're gonna add another output and we're gonna write the name of the test with test description. And that test IED is an argument that has default value and user can change. That corresponds to this. So again, SDS8 and message SDS8 test description, which is again variable that is entered by user or provided by default. That is this. Create and delete persistent data set several times. Again, these lines up and bottom are also provided in the screen. When that message is completed, program requires device under test to perform so-called discovery server. Discovery server is basically part in which program brings the ID model, online ID model, so that into the program, so that program knows what are the model and values currently in the device under test. Then program moves to loop test. If we look into inside of that flowchart, type of program starts with the delay and starts with create dataset IC6750 service. So basically, client is saying, okay, create a data set. And as you create data set, please send this output message to output window and to the file. And text is create dataset iteration. Counter is a variable that is associated with my program, and it is not argument, it is variable. So if I look at the variables, there will be variable called counter here. It's integer 32 and default value 1. So obviously the counter value at this point will be 1. So the test the program will send a message that says create dataset iteration 1, and then result of the message, create dataset result with message converted to string, that so it can be outputted. The test result is this create dataset iteration, and the result is success. Now, when the create dataset is issued, there are two possible outcomes, positive and negative. Let's see if really decides to reject creating dataset. If that's the case, then this message will be created. On iteration 1, we have a failed of create dataset. And this test error Boolean variable will be set to true. However, if the program, if the relay or device under test successfully creates data iteration, then we'll follow with action delete dataset, and we'll place a message delete dataset in iteration 1 with delete dataset respond set to converted to string. Now, delete dataset could also go positive or negative, and program handles that positive and negative test scenarios, and it's creating the value for counter, increases the counter, and if there is any error, creates puts the alarm to test error variable. When that is completed, this will be executed 250 times, or as long as the counter is less than 251, and test error that can be set in these negative responses is not false. It's actually false. So as long as we don't have any error in responses, do 250 times this particular loop. And as a result, this will go and run 250 times this program, this create dataset, delete dataset action. Now, if it happens that we do have test respond for create or delete dataset as a fail, this test error will be true, and if test error will be true, this loop will be completed and exited, and this part of the code will be active. So if the test error is true, then we'll have this output that says test failed. However, if test is false, then we'll have result test pass. When that is outputted, release is issued, and program is terminated. As you get familiar, you will be able to fully understand how this workflow works. But good thing is there are so many programs already written for different aspects. And if you are dealing with create and delete data set several times, you can actually come to that place. This is the function. okay, that deals with loop that creates and deletes data set. Well, what you can do is you can copy and move into your new program. Let's open another one. Well, I can drop here. Okay. So as you can see, I dropped this program and I can move this program anywhere I want. And I can move it from here. I can quit this, not save it. I can open different program. And I can paste it. So copy paste work perfectly fine. Just remember, when you are doing there you go, it's here. So when you are doing copy paste, remember that this program might rely on certain variables, like this variable. And you might get some errors that these variables are not available, and therefore you need to fix that. So you will be notified by these errors that one or more children have validation errors, warnings. You just go and fix them one by one, add your variables that are needed with your copy and paste actions, and they will disappear. So again, reuse of the code is quite possible. And for that reason, you can focus on learning certain sections of the program. So focus on, for example, publish goose flowchart. This is what it says, what it needs. If I'm putting a data set, I gotta deal with quality, timestamp, and integer. This is where I'm gonna start publishing. This is the message. Now, how many times? Well, here, I got some flowchart that is looking at the first publish goose message. If it's correctly published, then counter is increased. There is a round quality and round integer, change quality, change integer, and update that goes back and runs until this max variable is larger than variable I. If anything goes wrong, you stop publishing and you write an output message to it. Now, this, if you test this and it works fine, and obviously these test cases that we gave you work fine, they're tested, you can then copy this and use it anywhere you want. And again, just remember to adjust variables to it. Okay, I'm going to quit that without saving. And what I wanted to tell you is the UCA test scenario programs that we gave it to you, or you acquired, they do have test cases with IED SCL file that has all necessary sections, capabilities through its services necessary to run this, for example, program. In the log file, you can see the program was executed, and there is a pickup recording that you can follow TCP stream and ensure that indeed this program ran correctly. So again, every single conformance block is loaded with the programs located in program folders, inside the program folders, you have the program itself, you have the file necessary to represent device under the test, and you have successfully completed test scenario. Now, test scenarios could be positive and negative. So for that case, there are some that will finish positive and some purposely to finish negative. But you will always have a reason for fail. Okay. UCA test scenarios are tests of positive test cases and negative test cases. Again, Grid Runner client. So some acquire license with Grid Runner client, and they get the designer workflow without these programs. This allows you to create programs and actually do the same thing that we did here. Or you can create some automated tests that can do some work for you, not necessarily UCA test scenarios. But the UCA test scenarios are useful because they run all these 61850 services that you will have in your program. So no matter what do you want to make, you will rely on 61850 services that are available here as object components. Now, again, with Grid Runner license, you can create and run your programs. If you don't have this license, you obviously can create your own programs, but you can't run these independent programs, even though they appear to be ready for execution without having any license. The case is they will actually look and check if you have a license. Now the UCA test scenario, if you have a Grid Runner client and UCA test scenario, then you can run these programs. You can edit these programs and utilize some of the code by using copy and paste functions. Okay, so that's Grid Runner client. It again comes with the training. The training has how to use test procedures, something that I just explained to you. The UCA test procedures are programs organized by control blocks. Each control block has names of the UCA test scenarios. You need a license to run them. When you run them, they show up as independent programs. On the left side is the user interface, something that user can change to run program on with the different IDs. Communication log, event log, and console will output information related to your program. The arguments here, you click on them, you will be able to make changes. This is the path to your SCD file, and so on. In the communication log, when your communication logs start presenting information, there is a filter editor that you can allow you to filter information based on your filters. To execute the program, you click on Run. And this is what you get in your communication log, and this filter can allow you to filter on certain things. The output files that are part of our programs, so you can write instruction for program to create text file and to output formatted information into the text file. Workflow Designer is a place where you can create new program or edit existing one. You can see the structure of your program. Okay, do you have any question? If you don't have this, yes.
Can you give me some test file?
Test file. Okay. I just explained. Okay, I just explained to you that the UCA test cases that you received have, for every test, there is a test file, there is a program, and there is output of the program when we execute it. So you got hundreds of files already available. And these files are associated with the programs that you have. Does that answer your question? Okay, I believe so. Because these test files are included in and you just have to ask your project management group or people that are dealing with transfer that we did, where are they located? So that would be it from Grid Software. We learn about discovery, we learn about SimLab, SCL Matrix, ID Builder, Sample Value Analyzer, Compare Grid Runner Client. Okay, if you want to really get good knowledge about it, you need to put a lot of time to learn about these products, especially Grid Runner, that is a very complex development environment that incorporates not only 6150, but also Microsoft stuff. Okay? So with that, yes?
What about the last week question about the cancel command?
No, our test software doesn't offer cancel command. You can't cancel.
I mean, when I have execute the select command and I want to cancel to continue another command.
Explain me, when do you need that?
I mean, when I press the select command.
Yes.
And I don't want to wait for the next execute command. I want to cancel that select command.
Okay. Well, the cancellation would happen with the time select before operate timer expiring.
Really, I want to take the cancel command manually by myself.
Okay. Okay. First of all, you have to find me the reason why we didn't implement, because no relay support that. Command terminate. There is no relay on the market that support that. And that's the reason I talked to our developers That's the reason why we didn't implement. So even if you have that feature, you would not find a relay that would accept your cancel command. Every relay would respond with negative respond and would wait for you either to perform operate or for select before operate timeout to expire. When the timeout expire, next command can be executed.
What happened when we set the timeout? The select timeout timer is very long.
Okay.
So we have to wait that.
Okay. First of all, my question to you is, you got to understand me. Which relay support cancel command?
I see that in every relay, it has the cancel logical node.
Cancel logical node. There is no such logical node called cancel. I'm going to open the 61850. Seven four. You said logical node cancel. Which is that logical node? There is no such logical node.
Sorry, I mean the control object.
Control object, yes. Now,
Can you open on one SCD file or CID file?
sure.
We have the control object.
No. Or actually, I should use discovery. Cancel here.
Yes, I mean that.
Wait a minute.
If the relay had this control object, it means it can receive the cancel.
Okay, let me see. You select cancel here. That's how you do it. You see? Operate, select, this is selection, cancel. Successfully cancel.
Can you read the cancel model?
Select, operate. Position reach, sorry. Select, cancel. Cancel. This is the respond from the test ID.
Can you see the timestamp has changed in the cancel object?
Well, I would have to run this. This is when, this is the time when the client send the control request. Cancel.
Can you check that time when you send the cancel command?
Now, the problem is here, I don't have cancel. So I can see the values multi-operator timeout. Get identifier, enable, close, enable, open, but there's no cancel in this model here. And the fact that here discovery is showing the whole model, but it doesn't show on, this cannot be basically updated because I'm not getting here cancel. So it might be that on Simlab cancel is not doing the right control. This is C switch position. C switch position. Okay, I need to see where this, so it is under ID control QA position, cancel control value. So I'm going to go here. Test control C switch control C switch. Select open. Just a second. So this is test ID control QA1 switch 1 position. No, I don't see the close, the cancel. It's part of the object, but I don't see it. Anyways, this indeed sends, actually we can look into this communication log. I'm going to clear this. I'm going to do, so this is performing whatever, but I'm going to do operate control, select to select cancel. Okay, I'm going to stop this. As you can see here, select issued, send select, confirmation that select was successful, begin cancel, cancel success. So you cancel it definitely by performing this action cancel. Again, operate, true, select, cancel. There you go, select. Let me get that. You happy with this?
Yes, that fulfill my answer.
Okay.
Thank
All right.
you.
Thank you, gentlemen. Thanks for having me. Unfortunately, I booked last week from Monday to and all this week we're all busy doing things. So the last day, the last 4 hours, you can send some questions. We will answer, provide you technical support through 4 hours remaining. So this completes our training. And again, there are plenty of these applications. You are giving quite good resources with presentations and files that you can run on your own and learn about Engineering Studio and other concepts of our products. With that, I would conclude this presentation. Thank you again, and have a great day.
Thank you very much.
Thank you.